Okay, so for Chapter 1, Section 2, there's quite a bit of information here, even though it's not very much reading. It's states of matter and classifying matter. So this should hopefully go pretty quick if I talk fast enough because it's very basic information. For example, the states of matter. You should know that it goes from solid to liquid to gas. You don't need to worry about plasma. It goes from solid, liquid to gas when we increase the temperature, which means the particles move faster, or we increase the thermal energy. If we decrease the temperature because the particles move slower or these substances release energy, then they'll go from being a gas to a liquid to a solid. If we talk about each one individually, we know that solids retain a not say constant, but they have a definite shape and a definite volume, meaning the shape of the spoon is going to stay the shape of the spoon. If you put it in a bowl, it does not take the shape of the bowl, it keeps the shape of a spoon. Same for this steel ball. The reason why is because the particles are very, very closely packed together that there's very little movement. They vibrate in place and that's it. This is due to the law of gravitational attraction. Well, actually, there's other forces involved too, but basically, when particles are really, really, really close together, they're very, very, very strongly attracted to one another. There's also different, like, how do I say, intermolecular forces, intramolecular forces, different things like that also play along in this. So again, solids have a definite shape and a definite volume, whereas liquids have a definite volume, but not a definite shape. Both of these containers contain the same amount of liquid. However, if you notice, the liquid has a different shape in each one. This is because even though the particles are close together, they're far enough that they can, I guess you could say, flow past one another. So again, liquids can retain their volume. So both of these have, let's say, 100 milliliters, but they take the shape of the container. Gases, on the other hand, do not have a definite shape or definite volume. Gases will take on the volume of whatever container they're in. They will take the shape of whatever container they're in. This is due to gas particles, I should say, being very, very, very far apart from one another because they move so quickly and there's not that much attraction. Now, the gas particles inside a container constantly bounce off each other and bounce off the sides of the container, as you can see in this diagram. Then, Chapter 1, Section 2 went into classifying matter. It talked about a pure substance, which is matter of a uniform or fixed composition. And there's two kinds of pure substances. There's elements, which is made up of one type of atom, and there's compounds, which is one type of molecule, which is another way of saying two or more types of atoms. So an element and an atom. An element can be any size. An element just means a pure substance of only one kind of atom. Again, an element can be any size, going from a single atom to numerous atoms, but it's all the same type of atom. For example, this bucket that's made from copper. This entire bucket is made of copper. It is a lot of copper atoms, but it's all copper atoms. Now, I kept using the word atom. What's an atom? An atom is the smallest particle of an element that still retains its properties. So, there are things smaller than atoms, such as protons, neutrons, and electrons. And there's things smaller than those. However, for an atom of copper, which has a very specific property, there has to be 29 protons, because that's what protons determine the element. So that's what makes copper copper. If you get smaller amount, if you take that and you divide it into smaller, and you look at just the neutrons or just the protons, it won't behave like copper. Copper behaves a certain way because it has a certain amount of protons, and that's the atom. Any more or any less, it's not an atom of copper. It would be something totally different. So again, element is a pure substance of only one kind of atom, going from a single atom to numerous atoms. A compound is a pure substance that's made with a fixed ratio of two or more atoms, or two or more elements, I should say. Once these, for example, water, and once these elements have combined, the properties of the individual elements are replaced by properties of the compound. So we have water here, but I'm going to do another example. Sodium chloride, NaCl. Sodium and chlorine combined makes sodium chloride. Sodium is a very reactive metal. It explodes in water. Chlorine is a very poisonous gas, but if you put them together, sodium chloride's table salt that's used for French fries. That is not a poisonous gas, nor is it an explosive metal in water. So as you see that when these elements combine to form a compound, the properties of the compound can be very different than the properties of the individual elements. Okay, and a molecule is just the smallest unit of a compound. Because again, if you have water, the smallest thing you can ever get of water is a single oxygen with 2 hydrogens attached to it. But then you can get a whole ocean full of water, which is numerous molecules of water. Well, a molecule is like an atom, except molecules just refer to a compound, where it's 2 or more atoms chemically combined. 2 more different atoms, I should say. Mixtures. We have heterogeneous mixtures and homogeneous mixtures. Hetero, the prefix hetero means different. Prefix homo means the same. And you can see in this picture that in here, you can easily see the layers, whereas homogeneous, it looks the same throughout. There's a pattern going on. So if we look at heterogeneous, the matter is not uniform in composition. Okay, both mixtures, heterogeneous and homogeneous, is multiple pure substances. But with a heterogeneous, it's not uniform. You can easily see the different parts. I can easily see all the different, I guess, food items that make up this Chex Mix. I can see the oil, the water, and the sand in this beaker. Different portions do not have the same composition, meaning if I take a 1-inch square area of this picture right here, notice I'll have a circle pretzel and some of these Chex Mix. But if I take a 1-inch square area here, that's mostly a rye chip. There was no rye chip in this one, whereas in this one there was. So equal portions do not have the same composition. The same can be said here. If I take a 1-inch square area, this has just water and oil, no sand. But if I take a same 1-inch square area towards the bottom, then I can get water and sand, or I can get just mostly sand and just a tiny bit of water. So again, the composition is not uniform. Whereas a homogeneous mixture, it is uniform in composition. And different portions, like I said, different portions have the same composition. So this brass coin here is 61.5% copper, 35.4% zinc, 3.1% lead. If I cut it in half, each half would still have the same percentages of these 3 elements. It doesn't matter. Every piece of this brass has 61.5% copper, 35.4% zinc, 3.1% lead. Same for this coffee here. Every single part of the coffee will have the same composition. And again, these are called solutions. Yes, a solution can be a solid, liquid, or a gas. And that's it for everything in Chapter 1, Section 2, States of Matter and Classifying Matter.